Hey guys, I know that some of you have been having a little bit of difficulty with the exponents because we've been doing a lot lately and there's a lot of properties to know. So what I thought is if I would do a video of all the practice problems from your worksheet today. So if you take out this worksheet that you see, we're going to skip to question number 4 on the back, and I'm going to do the practice problems that you have. If you look at question 4, the directions say to rewrite the expressions in exponent form. That means we're going to do IO, inside over outside. Remember that if you don't see a number here, that little root is a 2. So if I did I over O for part A, that's like 5 to the inside 1, outside 2. For part B, 5 to the inside 2, outside 3. Part C, 5 to the inside 3, outside 2. They didn't show me the square root, but there it is, it's a 2. And then part D. Part D is a little bit interesting because they wrote the 2 on the outside, but please remember this is equivalent to the cubed root of 5 squared. And that's all based on 5 to the 2/3 being able to be written as 5 squared to the 1/3 or 5 to the 1/3 squared. All of those properties go together. So this is actually equivalent to B in that it's also equal to 5 to the 2/3. As long as you know this little 3 is the root and always goes on the bottom, you'll be good. In number 5, they ask you to rewrite in the form k times x to the n. That means that there are no variables or x's in the denominator. So now I look at a. There's no denominator, so that's good. I'm going to keep 2x cubed. I'm going to keep 3x to the 5th. But I'm going to multiply and distribute that 2 to both the 6 and the x in that last term because of the parentheses. So I'm left with 2 times 3 times 6 squared is 36. And if I multiply all of that out, I get 216. And then I've got x cubed times x to the 5th times x squared. When you multiply, you add exponents. So 216 x to the 10th. Now part B, no x values in the denominator. So I'm going to write 3x to the 4th here, but instead of having a denominator, what I need to do is move that negative 6x in parentheses to the numerator. If I do that, the sign of the exponent changes. So that gives me 3x to the 4th. Negative 6 squared is 36, and x squared stays. If you multiply, 36 times 3 is 108, and x to the 4th times x squared is x to the 6th. For those of you that are a little confused there, if you go to your calculator and you type in negative 6 in parentheses and then squared, I'm going to just do it over here since I have the overlay out. If you type it in exactly how that looks, your calculator will give you positive 36. And that is because any quantity being squared becomes positive. I'll just do C with you. C, if I want there to be no denominator with variables, I'm going to keep my x to the negative 3, keep my x to the 5. 3 is okay in the denominator, but I'm going to bring x to the 4th up because I'm not supposed to have variables based on this form, k times x to the n. So that gives me 1/3. Remember, there's an imaginary 1 here, so pull out the number 1/3. And then my x term, negative 3 plus 5 is 2, minus 4 is negative 2. So here's the first example in this section where you can actually see k in front, 1/3, and n, negative 2. It's a little easier to see here because k is a fraction. If you refer back to, let's say, example A, K is 216 and N is equal to 10. Okay? I'm going to skip part D and move down to question 6. Question 6 asks you to simplify using only positive exponents. So my first step is to rewrite the denominator with a positive exponent. So I'm going to actually bring it up to the numerator and change that -2 to a +2. Now I'm going to distribute that 2 to each term. So I still have 3x to the -4th, y to the 5th, but now I have 2 squared, which is 4, and x cubed squared, power to a power, you multiply, so that's x to the 6th. And then y to the -7 squared is y to the -14. Now, combining like terms here and multiplying, 3 times 4 is 12. X to the -4 times x to the 6th is x squared. And y to the 5th times y to the -14th is y to the -9th. So that's wonderful. That actually would be your answer if it said k times x to the n or y to the n. But they wanted positive exponents, so I've got to get rid of that -9. I can change the sign of the exponent by moving it in the fraction to the denominator. Okay. We're going to skip 7. If you want, you can put that right into the calculator. It is choice 3. And we're going to move on to question 8. In question 8, it asks you how 2 to the 1/3 to the 4th power can be rewritten as this radical. So the first thing I would do is the power rule and make that 2 to the 4/3. If you don't know how to multiply fractions, you can put it in your calculator, 1/3 times 4, and then math frac it if you don't get a fraction. But what I did was really just make that 4 over 1. And 1 times 4 is 4, 3 times 1 is 3. So now what I'm going to do is notice that they want that as a radical. So I've got 2 to the 4th and the cubed root of that. The reason is I've got like we did in the beginning. Inside 4, outside 3. And that's all equal to the cubed root of 16 because 2 to the 4th is 16. Now, if you're asked to explain that, if it says explain, half the credit means write in words what you did. So to explain, I would say I used the power rule to rewrite 2 to the 4/3, and then I rewrote my answer as a radical with a cubed root. Something to that effect, or stating that you use the properties of exponents. Okay, I'm going to do a few more problems from here, and if I don't do a problem that you're having difficulty with, please see me in extra. If you look at question 9, part A and B are asking you that k times x to the n again. So if I was going to do A, I would distribute this -3 to all of the pieces inside the parentheses, making that x to the -6, because 2 times -3 is -6, over 4 to the -3, and x to the +3. Now, if you want to, you can rewrite this as 4 to the +3, change the sign of the exponent, move it to the top, x to the -6, and then x cubed. 4 cubed is 64, and when you add those together, you get x to the -3. So if you were identifying your values there, k is 64, and x is -3. Oh, my fault. Hold on. Oh no, that's good. And x is -3. My fault, my fault. Okay, this is 64, This is x to the negative 6. When you bring up the 3, it should become x to the negative 3. So instead of x to the negative 6 times x to the negative 3, you have x to the negative 9, because when you multiply, you add those exponents up. Sorry about that, guys. Take a look at question number 10. If you are asked which expression is equivalent, a lot of times they could do this on the Regents. What I would do if I was you is I would rewrite this as 1 over 9x squared y to the 6th to the positive 1/2. Now, if you realize that this means just take the square root, that's fine. If you don't realize that, then rewrite it as 9 to the 1/2 x y cubed. How did I get those numbers? Well, I distributed the 1/2 to each term inside the parenthesis. 2 times 1/2 is 1. 6 times 1/2 is 3. Think about it as half of 6 and half of 2. That gives me 1 over 3, put it in your calculator if you're not sure, xy cubed. So that is choice 1. Number 11 is similar to that. You can rewrite this as 1 over the square root of a squared b to the 1/2. But now, if they want us to give the answer, this is the same thing as 1 over a squared b to the 1/2 to the 1/2 power. Inside of all of that is 1, outside is 2. Actually, you could do them separately if you wanted to as well. So this gives me 1 over a times b to the 4th, because when you have a power to a power, you're going to distribute and multiply. 2 times 1/2 is 1, and 1/2 times 1/2 is 1/4. So that gives you choice 4. We'll skip number 12. It was on your test. Just my hint for that is to rewrite it as 1 over x squared minus 1 to the positive 2/3 first. When you do that, you should get choice 2 using IO. Number 13, this was a Regents question. There's a few ways you can do it. What you might want to consider doing first is what's on the inside. If you rewrite what's on the inside, you get w to the 9th over w to the 5th to the 1/2. I changed the signs of those exponents to be positive by shifting their location. That's w to the 4th to the 1/2. And now that you have a power to a power, you get w squared. It's not the only way to do it. If you get w squared another way, I'm sure it's fine, but if you want me to check it, come see me after school and I'll do so. We're going to skip 14. If you did it, it's choice 4. 15 we'll skip as well. That's choice 1. And we'll go to 16. This was a Regents question. If they're asking you what's equivalent, look at your answers. They all have positive exponents. So the first thing I'm going to do is rewrite this with positive exponents. If I look in my numerator, x has a -1 exponent. I want it positive 1, so I'm putting it in the denominator. Y to the 4th is positive, so I'm keeping it. 3 has an exponent of 1, so it stays in the denominator. X to the -5 should become positive, so I put that in the numerator. Y to the -1 should become positive, so I put it in the numerator. So change the sign of the exponent if you move the variable. So altogether, I have x to the 5th, y to the 5th, over 3x, which isn't a choice because you can do more. X to the 5th divided by x is x to the 4th. Keep the x to the 5th and divide by 3. So your answer is choice 1. If you did question 17, it's choice 2. If you did question 18, it is choice 4. Those are just substitution. In this question, you just put a 3 for x and use your calculator. And in this question, you put a 4 for x and use your calculator. And that's really how you do all of this exponential stuff. So I didn't really go through and teach you the lesson again, but I guided you through, and I hope it was helpful for completing these problems. See me in extra help.